How did I build this camera? What if I told you that you can achieve the professional image quality of cameras costing thousands of dollars with your own hands? And all with a Raspberry Pi. I'm sharing every single detail of how I brought this professional camera system, which I've named ShutterPi, to life after months of hard work. If you enjoy these kinds of maker adventures, don't forget to subscribe before we dive in. Tested during a breathtaking sunrise in Cappadocia, ShutterPi, with its 4K 30 FPS recording power and compact body, is not just a hobby project, it's a true engineering marvel that has proven itself in the field. Now, without further ado, let's see what's inside this beast and get started with the setup. We made no compromises when building the brain of this system. At its heart is the 8GB RAM version of the Raspberry Pi 4, ensuring a smooth interface and lag-free 4K previews. This dual-fan setup keeps the Raspberry Pi cool and performing at its peak by preventing overheating even under heavy workloads. And next, the essential Waveshare UPS Hat-B, which turns ShutterPi into a portable camera. Notice this, I added a custom power button for easy access without touching the original switch. Supporting 3 hours of shooting with two 18650 batteries, this board represents the true freedom of ShutterPi. This means no more cables, just completely professional and uninterrupted shooting anytime, anywhere. For the interface and preview, I chose the Waveshare 4.3-inch DSi touchscreen. With its 800 by 480 resolution and responsive touch, managing camera settings becomes incredibly smooth. The power behind our image quality, the Aducam IMX477. This 12.3 megapixel HQ sensor, paired with a 6mm lens, provides a wide field of view and captures incredible detail in 4K video. Its C and CS mount support opens up endless possibilities for professional optics. To light up the scene in low light conditions, I used this 3-watt LED module. This powerful flash integrated into ShutterPi helps us capture sharp photos in any environment. Sound is just as important as the image. Thanks to this mini USB microphone, ShutterPi doesn't just take photos, it also captures clear ambient audio for all your video recordings. These flexible flat cables act as the system's nervous system, connecting the Aducam and the touchscreen. They ensure seamless data flow and a responsive touch experience within the tight space of the enclosure. I used these male and female jacks specifically to extend the UPS Hat-B's charging port to the exterior. This way, I don't have to open the body to charge the batteries, I can simply power the system through this external port. To fit the form of my 3D printed case, I crafted this custom USB male-to-female cable. This allows us to extend the Raspberry Pi's USB port to the outer shell in the most efficient and aesthetic way possible. I use these 3 momentary buttons for physical camera controls. They allow us to quickly start recording and handle zoom in and zoom out functions without ever needing the touchscreen. And finally, we use various sizes of M2 and M3 screws and brass inserts to secure all these components to the 3D printed case. I custom modeled the body to house all these electronics with millimeter precision. I went through multiple revisions of this printable 3D camera design to ensure it's both ergonomic and perfectly fitted for every component, reaching the final form of ShutterPi. To ensure the screen fits perfectly and remains stable, I designed this screen mounting frame. This part not only protects the display from external impacts, but also provides a professional finish to the front of the device. Now for the iconic detail that defines the face of ShutterPi, the camera lens ring and LED housing. This orange ring isn't just a visual signature, it centers and secures the lens to the body. The slot directly above it was custom designed for our 3-watt LED module. This ensures the lens and flash unit look integrated and professional as a single piece. This color contrast is one of my favorite details, giving the project that perfect retro camera vibe. Here is the foundation of the project, the camera body. I designed this main chassis by carefully calculating airflow and cable management. With ventilation holes on top and integrated mounting points on the sides, ShutterPi becomes both durable and compact. This dual fan holder secures the cooling system, ensuring the fans are perfectly positioned over the processor. Beyond the hardware, the heart of ShutterPi is this custom application I programmed with Python. I designed the kiosk interface for a touch-optimized experience with instant access to all controls. The app is fully open source, so anyone can develop it and add new features. In this series, you'll also see step-by-step how to install this application on Raspberry Pi Lite. We can quickly switch between photo and video modes. Using H.264 hardware acceleration, we record smooth 4K video while pushing the Pi's power to its limits. My favorite feature is the real-time face detection and smart focusing powered by the Haar Cascade algorithm. For a cinematic look, I added 3D LUT support to apply professional dot cube filters on the fly. All parameters, like brightness and white balance, can be optimized through the app alongside hardware-based zoom. Audio management is very practical. The system recognizes any USB microphone instantly. Once the recording ends, ShutterPie automatically converts files into .mp4 format. You can review everything you capture through the built-in gallery UI without ever leaving the app. I also included a screen lock to prevent accidental touches during field use. ShutterPie is a true professional with hardware and software working in perfect harmony. Stay tuned to learn how to set up your own application. But the excitement doesn't end here. A much more detailed and technical journey awaits you in the rest of the ShutterPie series. In the next episode, we'll see how the iconic orange ring, the signature of the design, the powerful LED flash, and the camera lens integrate perfectly with the body. I'll guide you through the tips and tricks of mounting the sensitive touchscreen and its custom frame, showing you exactly how I handled even the most complex cable management step by step. Finally, we'll witness how all these components come together in the main chassis to achieve ShutterPie's professional final look. But our work isn't limited to hardware. In our third video, we'll flash the Python code I wrote onto the SD card, complete the software settings, and put ShutterPie through its paces in real-world conditions. So, how does all this technology come to life in a single body? I'll see you in the next video for the exciting assembly process of ShutterPie. To support me on this journey, don't forget to subscribe, like the video, and be sure to write in the comments. I'd love to hear your thoughts and questions. See you in the next technical adventure.